In Unit 64, we are going to start taking a look at right triangle trigonometry. And something we want to remember is called SOHCAHTOA. Okay? I'm just going to leave that there for a minute, and then we're going to go back and we're talk about it a bit. But I want it to be one of the first things you heard about this unit because it's important. So, first thing you want to make sure we know how to do is how to name the sides of a right triangle. Now, in the bottom left in this triangle is your right angle, and that's denoted with this green symbol I just put in. Always across from the right angle is going to be your hypotenuse every single time. It's always going to be the slanted one across from the right angle. Now, your opposite side and your adjacent side are going to depend on the other angle that you are looking at. So, if we call the bottom right angle, we'll just say angle X, based off that angle, okay, the adjacent side is going to be the side next to the reference angle. So this is your adjacent, okay? Based off this angle X, the one that's now across from it is your opposite, okay? If we looked at another triangle, so let's draw one over here. Okay, if I'm looking at this angle as angle Y, I'll call it. This is still my hypotenuse. That doesn't change because of the right angle. Now, this one becomes my opposite, and the one connected to it is my adjacent. Okay. So there are three different pairs that we are going to look at for trigonometric functions using the ratio method. So now we're in the upper right. The three different pairs can be formed using three sides of a triangle, and they're going to be opposite and hypotenuse, adjacent hypotenuse, and opposite and adjacent. From these relationships, we can come up with the 6 ratios that you see below. Okay, so the first part of them, the 3 most commonly used ratios are sine, which is equal to the opposite over the hypotenuse, the cosine, which is equal to adjacent over hypotenuse, and the tangent, which is opposite over adjacent. But let's say we can't remember that. Instead, now we're going to go back to SOHCAHTOA. We can say sine is equal to O is opposite over H, which is hypotenuse. Cosine is equal to adjacent, the A, over the hypotenuse, the H. And then tangent is equal to the opposite over the adjacent. So that's where SOHCAHTOA comes in. More importantly, we have 3 other ratios to look at. Okay, that's the other 3 ratios are reciprocals of the first 3. So to get cosecant, you take your sine, flip it upside down. To get secant, you take your cosine, flip it upside down. And for cotangent, you take your tangent and you flip it upside down.